Hello everyone, welcome to CH for us. In this video, we'll be solving problems related to mole concept. We'll see the first question. Calculate the mass of an atom of silver, a molecule of carbon dioxide. First, we will solve mass of an atom of silver. Silver is represented as Ag. Ag is the symbol of silver. Okay, is equal to how much? The atomic mass of silver is equal to 108 units. For certain elements, you have to remember the atomic mass so that you can solve the problems easily. Okay, sometimes they'll not given the question that the atomic mass of this element is this much. Now, 1 mole of silver atom is equal to 108 grams. This is the gram molecular mass. But as it is an atom, it is gram atomic mass. It is not gram molecular mass, which is equal to 6.022 into 10 to the power 23 atoms of silver. Okay, you have to keep this in mind. Now they are asking us to find the mass of an atom of silver. How do you find the mass? Mass of any atom is equal to gram atomic mass by Avogadro's number. This is the formula. In this problem, we are finding the mass of an atom or mass of a molecule. What is the gram atomic mass of silver? 108 grams by Avogadro's number 6.022 into 10 to the power 23, which is equal to, when you solve this, you'll get 1.793 into 10 to the power minus 22 grams. This is the mass of an atom of silver. Therefore, now B. Calculate the mass of a molecule of carbon dioxide. Mass of CO2 molecule is equal to how much? 1 mole of CO2 is equal to, what is the gram molecular mass of CO2? 12 is the atomic mass of carbon plus 16 twos are 32. 16 is the atomic mass of oxygen, and we have 2 atoms of oxygen in carbon dioxide. So the gram molecular mass of CO2 is 44. 44 grams is equal to 6.022 into 10 to the power 23 molecules of CO2. Fine. Now they are asking us the mass of CO2. Mass of molecule, of any molecule, is equal to gram molecular mass by Avogadro's number, which is equal to 44 is the gram molecular mass of carbon dioxide by 6.022 into 10 to the power 23. That is the Avogadro's number, which is equal to, the answer will be 7.307 into 10 to the power minus 23 grams. You have to do the calculation. I'll just show you how to do the problem. You have to solve and write the correct answer. Okay. Now, this is the first question. Now, we'll see the second question. How many atoms and molecules of sulfur are present in 64 grams of sulfur? The atomic mass of sulfur is equal to 32. Okay, 32 AMU. Now, 1 mole of S8 sulfur molecule is equal to 32 into 8, which is equal to 256 grams. This is the gram molecular mass, which is equal to 6.022 into 10 to the power 23 molecules of S8 sulfur molecule. Now they are asking us to find the number of atoms and number of molecules present in, this is the main important thing, 64 grams of sulfur. In 1 mole of S8 we have 256 grams. 256 grams of S8 contains 6.022 into 10 to the power 23 molecules of S8. Then 64 grams of S8 is equal to how much? 64 into 6.022 into 10 to the power 23 by 256, which is equal to 1.506 into 10 to the power 23 molecules. You have to solve and write. Okay, I will be giving you the final answer. You have to solve it and write. Okay, this is the number of molecules. We have to find even the number of atoms present in 64 grams of sulfur. So you have to just multiply 1.506 into 10 to the power 23 into 8, because in sulfur molecule we have 8 atoms of sulfur. So directly you can multiply this with 8. You will get 1.2048 into 10 to the power 24 atoms of S8. Okay, so this is the second question. Now we will see the next question. Calculate the number of molecules. Number of molecules you have to find in this question. Number of molecules is equal to how much? In 34.2 grams of cane sugar. Okay, first one is number of molecules in 34.2 grams of cane sugar. Cane sugar formula is C12H22O11. First we'll calculate the molecular mass of C12H22O11, which is equal to 12 carbons into 12. 12 is the atomic mass of carbon, plus 22 hydrogens into 1, plus 11 oxygens into 16. 16 is the atomic mass of oxygen, which is equal to 144 plus 22 plus 176, which is equal to 342 grams. Okay, as it is a molecular mass, you should not write it as grams, you should write it as atomic mass units. When we mention it in grams, we can write it as 342 grams. Now, 1 mole of cane sugar is equal to 342 grams. This is the gram molecular mass of cane sugar, which is equal to 6.022 into 10 to the power 23 molecules of cane sugar. Okay. Now, in 34.2 grams of cane sugar, how many number of molecules are present? In 34.2 grams of cane sugar, the number of molecules of cane sugar is 34.2 into 6.022 into 10 to the power 23 by 342, which is equal to 6.022 into 10 to the power 22 molecules of cane sugar. Okay. You have to solve this again. See, this 34.2 into 10 you should do. You'll get 342. 342 in the numerator and denominator gets cancelled, and the final answer will be 6.022 into 10 to the power 22 molecules of cane sugar. First one we have completed. Now we'll see the second one. Calculate the number of molecules. Number of molecules present in 1 liter of water. In 1 liter of water is equal to how much? Okay, whose density is given here, 1 gram per centimeter cube. Okay, first 1 mole of H2O is equal to 18 grams. This is the gram molecular mass of H2O, which is equal to 6.022 into 10 to the power 23 molecules of H2O. Now they have given that the density of water is equal to 1 gram per centimeter cube. Gram per centimeter cube is a unit for density. You have to find the mass of 1 liter of water, which is equal to how much? We know that density is equal to mass by volume. So if you want to find mass, you have to multiply density with volume. Density into volume is equal to mass. So what is the density? 1 gram per centimeter cube. Into what is the volume here? 1 liter. So you have to keep this in mind. 1 liter is equal to 1000 milliliter, which is equal to 1000 centimeter cube. Okay. So 1 liter is, here they have given 1 liter. 1 liter is 1000 centimeter cube. We are taking it in centimeter cube because to cancel this. Okay, in the density we have centimeter cube, right? So to cancel that and to get the mass in grams, we have to take it as 1000 centimeter cube. Mass is equal to 1000 grams. Mass of 1 liter of water is equal to 1000 grams. Now, 18 grams of water contains 6.022 into 10 to the power 23 molecules of water. Then 1000 grams of water contains how many molecules? 1000 into 6.022 into 10 to the power 23 by 18. So the final answer will be 3.346 into 10 to the power 25 molecules of water. Okay. Now the third one, we have completed the second one. Third one also, you have to find the number of molecules. Number of molecules present in one drop of water having mass 0.05 grams. 18 grams of water, okay, generally 1 mole of water contains 18 grams, right? 18 grams of water contains 6.022 into 10 to the power 23 molecules of water. See, right, from this, there is that water, yeah, 1 mole, 18 grams, 6.022 into 10 to the power 23. So 18 grams contains 6.022 into 10 to the power 23 molecules of water. Then for 0.05 grams, 0.05 grams is equal to how much? 0.05 into 6.022 into 10 to the power 23 by 18. So the final answer will be 1.673 1.673 into 10 to the power 21 molecules of water. Okay, that is the final answer. You have to do the calculation part. Now we'll see the next question. Calculate the number of atoms of the constituent elements in 53 grams of Na2CO3. Constituent elements in Na2CO3 are sodium, carbon, oxygen. Okay, so this Na2CO3, it is an ionic compound. Okay, we have seen atoms, molecules as well as ionic compounds. Na plus and CO3 2 minus. When we do the crisscross method, we will get Na2CO3. In Na2CO3, we have two sodium Na plus ions and one CO3 2 minus ion, which is carbonate ion. Okay, now we have to calculate the number of atoms. 1 mole of Na2CO3 is equal to, what is the gram molecular mass? But here you have to tell it as gram formula mass of Na2CO3. Sodium is gram formula mass of Na2CO3 is equal to sodium 23 is the atomic mass of sodium into 2, because we have two sodium atoms here, plus 1 carbon 12 into 1 plus 3 oxygens 3 into 60. Okay, 16 is the atomic mass of oxygen, 3 is number of atoms of oxygen present in Na2CO3. So 46 plus 12 plus 48 is equal to 106 grams. Okay, 106 grams. 106 grams. 1 mole of Na2CO3 is equal to 106 grams, which is equal to 6.022 into 10 to the power 23 molecules of Na2CO3. But here they are asking for 53 grams of Na2CO3. The number of atoms present in it is 106 grams contains 6.022 into 10 to the power 23 molecules of Na2CO3. 53 grams contains 53 into 6.022 into 10 to the power 23 by 106. 53 ones are 53 twos are. 2 ones are 2 threes are 0 1 1, which is equal to 3.011 into 10 to the power 23 molecules. You cannot say molecules here. Even here you cannot say molecules. What did I say? Ionic compounds, you have to mention it as formula units. Okay, formula units. of Na2CO3 is present in 53 grams. Now you have to find out the number of atoms. So for Na plus ions, the number of Na plus ions in 3.011 into 10 to the power 23 formula units of Na2CO3 is 2 into 3.011 into 10 to the power 23 Na plus ions. Okay, in these many formula units of Na2CO3, we have 6.022 into 10 to the power 23 Na plus ions. Okay, now number of carbon atoms. How many carbon atoms are present? 1. So you don't have to multiply anything here. Directly you can take 1 into 3.011 into 10 to the power 23 carbon atoms, which is equal to 3.011 into 10 to the power 23 carbon atoms. Now, number of oxygen atoms. How many oxygen atoms we have in Na2CO3? 3 oxygen atoms. So 3 into 3.011 into 10 to the power 23 is equal to 9.033 into 10 to the power 23 atoms of oxygen is present in 53 grams of Na2CO3. Okay. Now, we'll see the next question. Calculate the number of molecules present in 350 centimeter cube of ammonia gas at 273 Kelvin and 2 atmospheric pressure. First, we'll write whatever is given in the question. We have to find out the number of molecules. Is equal to how much? Given volume, V1 is equal to 350 centimeter cube. Temperature T1 is equal to 273 Kelvin. Pressure P1 is equal to 2 atmospheric pressure. This is the given conditions. Now at STP, you have to find the volume of ammonia gas at STP. V2 is equal to how much? In STP, at STP, what are the conditions? Temperature is 0 degree centigrade, that is 273 Kelvin, and pressure is 1 atmospheric pressure. So temperature here is 273 Kelvin and the pressure P2 is equal to 1 atmospheric pressure. So from ideal gas equation PV is equal to nRT, we can write that P1 V1 by T1 is equal to P2 V2 by T2. Okay, this is gas constant. R is gas constant. So when we substitute P1 V1 T1 P2 V2 T2, what will be getting? 2 into P1 is 2 into V1 350 centimeter cube by T1 is 273 Kelvin is equal to P2 1 atmosphere into V2 is what we have to find out, and T2 is again 273 here at STP conditions. 273 gets cancelled. Now V2 is equal to 700. 2 into 350 is 700 centimeter cube. This is the volume of NH3 at STP. Okay. Now you have to find out the number of molecules present. So in 1 mole of NH3, okay, 1 mole of NH3 is equal to, one second, calculate the number of molecules present in 350. Yeah, in 1 mole of NH3, we have 6.022 into 10 to the power 23 molecules of NH3. What is the mass here? Okay, volume here is 700 centimeter cube. Here you can write 22.4 liters as 22,400 centimeter cube, right? I have already said that 1 liter is equal to 1000 milliliter, which is equal to 1000 centimeter cube. So 22.4 liters is equal to 22,400 milliliters, which is equal to 22,400 centimeter cube. So 1 mole of NH3 is equal to 6.022 into 10 to the power 23 molecules of NH3, which is equal to 22,400 centimeter cube. So if 22,400 centimeter cube contains 6.022 into 10 to the power 23 molecules of NH3, then 700 is what the volume we got for the ammonia gas. 700 centimeter cube contains how many molecules? 700 into 6.022 into 10 to the power 23 molecules by 22,400. So our final answer will be 1.882 into 10 to the power 22 molecules of ammonia NH3 is present. Okay. Now this is method 1. This is how you solve. Method 1. There is another method. Okay. 1 second, I'll wrap the board. Okay. We have method 2 where we'll be taking PV is equal to nRT. Okay. So P is 2 into volume. Volume will take it as okay 350 centimeter cube, can be written as 0.35 liters. 0.35 liters is equal to n is number of moles, okay, into R is gas constant, R 0.0821 into temperature 273 Kelvin. So number of moles will be getting it as 2 into 0.35. You have to take all this the left hand side by 0.0821 into 273. So somewhere around 0.0321 or 12 moles. Number of moles is equal to 0.0312 moles you will be getting, and we know that number of moles is equal to number of atoms by Avogadro's number. You have to take this Avogadro's number to the left hand side. Number of moles into Avogadro's number is equal to number of atoms. So what is number of moles? 0.0312 into Avogadro's number 6.022 into 10 to the power 23, which is equal to 1.88 into 10 to the power 22. Okay. This is not atoms, molecules. Okay. You have to find number of molecules. The formula is number of moles is equal to number of entities. Entities can be atoms. If they have given atoms, you have to mention atoms. But in the question, they have given molecules. So number of entities is number of molecules by Avogadro's number. You will be getting 1.88 into 10 to the power 22 molecules of NH3.